I'm going to describe the simulation on the left that is a way to help visualize what we mean when we have partially miscible liquids. So let's look a little bit at the simulation. So this is a snapshot and it shows what we can change. We can move this black dot around by changing the temperature, moves it up and down, or changing the overall composition, moves it left or right. And then what we're displaying here is what is the mole fraction of A in each of the two phases. So the idea is we mix pure A and pure B. In this case, we mix them in a 60-40 ratio. And so the rectangles, the boxes, are proportional to the amounts. And then we end up with two phases, not one phase, but two phases that contain both components. The beta phase has only 32 mole percent, or mole fraction of 0.32 of component A, so it's majority blue molecules, and the alpha phase is 66% of molecule A, and so therefore the majority of the molecules are the green molecules corresponding to component A. So we can see the compositions depend on temperature, and as we go to higher temperatures, we move outside of this phase envelope. In this region here, we only have one phase. And so the idea is to help understand a little better this idea of partially miscible liquids. And so let's go and look at the simulation. So here on the interactive simulation, you can see as we lower the temperature, we change the compositions, and we have a wider composition range where we have partially miscible behavior. So I can change the mole fraction, and you can see the amounts of A and B that we're mixing together changes, and then depending of course on where we are in the mole fraction, then the amount of beta phase is increasing as I decrease the mole fraction of A, and the amount of alpha phase is decreasing. And I can lower the mole fraction so that we only have one phase. This one phase only has 5% component A here, as represented in this representation on the right. Now, at higher temperatures, of course, high enough temperatures, we only have one phase. And as we raise the temperature, the composition range where we have phase separation, partially miscibility, decreases. So hopefully by using this simulation, get a better idea of the behavior of two liquids that are only partially miscible.